The video, I request you all to please click on the like button, and then you will see a hi button, so please click on that to support me.
TLC or thin layer chromatography is a separation technique which is used generally to separate a mixture of dyes and organic compounds and determine their purity and their RF value. So for that we need a glass slide, okay, and we also need some, this is silica gel. This will act as our adsorbent material. So first we have to prepare a slurry of silica gel. For that we take some water in a small beaker and to it we add silica gel. Add the silica gel and mix it well with the water to prepare a slurry. Keep on adding silica gel until you get, keep in mind that there should be no lumps inside the slurry. It should be thoroughly and consistently mixed. The slurry should not be thick, nor should be too thin. If accidentally you add if you add excess silica gel, dilute it with some water. So we need a slurry of this consistency. You see, this should be the consistency of your silica gel slurry. Now take your glass slide and spread the slurry onto it. Now keep this glass slide horizontal carefully and leave it to dry in air for few minutes. Dry, it will look like this, but it's still not ready for use. For that you have to keep it in oven at 100 degrees Celsius for 1 hour to activate it. Meanwhile I was drying my TLC plate in the oven. I prepared TLC chamber. This is a beaker. On top of it I have kept an watch glass, and inside there is a solvent. Here I am using water as the solvent, okay, but generally it is not being used. Other solvents like hexane and ethyl acetates or a mixture of some solvents are used, but here for demonstration purpose I am using only water. For spotting I am using potassium permanganate and green food dye. Over here I am using a green food dye. It says that it has tartrazine and brilliant blue color in it. So therefore I will be separating tartrazine and brilliant blue from thin layer chromatography. Now we also need some capillary tubes. These are capillaries. These will be used to spot the TLC plate. Now take your TLC plate and take your capillary, dip it in the solution. As you dip it, the solution will climb on the capillary. Now very carefully you have to make a spot on the TLC plate. See, we have made a spot on the TLC plate. Now take another capillary and this I will dip it into the potassium permanganate solution. See, and then I will make a spot. the spots are made very carefully in a horizontal line. Now this TLC plate will be kept in the TLC chamber. And you can see that the solvent is rising. As the solvent rises, the spots are being carried away by the solvent. So you know that here we use potassium permanganate as our. So let me tell you some advantage of thin layer chromatography, that how it differentiates to paper chromatography. In paper chromatography we use a absorbent material, and in this we use an adsorbent material. And you can see that we use potassium permanganate. If we would have used paper, potassium permanganate would have stained the paper brown, and we could not have got a purple spot. So we cannot use potassium permanganate in paper chromatography, but we can use paper in potassium permanganate in thin layer chromatography. As you can see, the purple spot is going high, leaving a brown stain of manganese dioxide. And on the left hand side you can see how the green color is getting separated into yellow and blue food dye. Now our solvent has reached the top of the TLC plates. Now it is the time to remove the TLC plate from the solvent, from the TLC chamber. You can see that there is a blue stain, and then there is a yellow stain, and in the middle there is a green transition stain. On the potassium permanganate side we get a good purple spot, and then there is a faint brown line that is due to the self decomposition of potassium permanganate. So here you know that we used only water as a mobile phase. If we would have used a mixture of solvents such as water and some other non-polar solvent or some organic solvent, there would be a better separation. So this was only a demonstration. In actual we use a mixture of polar and non-polar solvents like hexane and ethyl acetate as our mobile phase, and other solvents such as methanol and etc. But here I have done only demonstration, that's why I used only water. Okay.
Now I will show you how we can monitor a reaction with TLC. So first I will take my substrate, which is acetonide in this case, and adding some of it into an ignition tube, and then I will be dissolving it in few drops of chloroform. After making a solution of acetonide in chloroform, our reactant sample is ready. The reaction I was doing was a nitration reaction. So I took some reaction mixture, quenched it with water, and then added some ethyl acetate to it in this Eppendorf. Now I will take some ethyl acetate layer from this Eppendorf and spot and make 3 spots on the TLC. One is the substrate, second is the co, and third is the reaction mixture spot. And then I will place it in 10% ethyl acetate and hexane solution. After the solution has climbed the TLC plate, I will take off the TLC plate carefully, and then I will let it dry. After drying, I will place the TLC plate in iodine chamber. Different methods of spotting are used. The most common one is the iodine and UV. So over here I am spotting with iodine. After keeping it in iodine, you can see that the spots are stained brown or yellow, and this is how a TLC looks like in the UV light.